And welcome everybody to the Daily Space Weather Show. How about another earthly directed coronal mass ejection? We'll be talking filaments, sunspots, coronal holes, even a minor proton event. Lots to talk about tonight at the Smash News Network least busted name in news. And what was I doing? Oh, I remember. That's the past 24 hours. That's SDO 193 plus 304 angstroms. And you might see a brightening happening there. That is a Hyder flare. And some of that ejecta is on its way to Earth. We'll tell you all about it. Here's the equatorial zoom, and you can see that filament. Part of it's still anchored. Part of it has collapsed and succumbed to gravity, sinking down back toward the chromosphere. And part of it has ejected and is headed pretty much directly toward Earth. We've got setting sunspots in the east and setting sunspots in the west and rising sunspots in the east as well. Also quite a significant coronal hole here rotating into the Earth strike zone. Yeah, the Earth strike zone. So exciting stuff going on as we ramp up closer and closer within the next, say, 11 months to solar maximum, and expect nothing but an uptick in coronal holes in the coming year or two. Here's a huge filament. We decided to just show you a nice close-up of that towering filament there as it becomes a prominence in the northwestern limb of the closest star. And here's a close-up of a rising filament in the southeastern limb as well. So another prominence down there, and yeah, it's a good time to be doing space weather. And of course, folks, we didn't just leverage ourselves here accidentally. I had nearly majored in cosmology in the mid-1990s. I realized that there was a huge hole in cosmology resulting from heliophysics. So, yeah, we've made it a massive web ring to benefit people like you. So check out the homepage if you haven't done so yet, smashomash.com. Help out the channel with clicks, and view our clips as well. Welcome to the Neo-Renaissance. Smashomash.com. You can find us all over social media at Smashomash. And check it out. Massive savings here at the Redbubble shop right now. Save up to 60% on select items. Today's featured product is Universum Liberate. Because if I could wave my magic wand, I'd set everybody free. The symbolism represents signal strength, security, and integrity. The spiral represents the Milky Way galaxy itself. The lightning bolt represents galactic scale reach. Look at the savings, 25% off. Lots of things there, 30% off. Again, up to 60% off some of the products there on the Redbubble shop. So if you're thinking about picking up gear, now's a great time to do it. Our third best seller there, the Galactic Federation Special Forces Unit Patch. If you're sick of bringing peace to the solar system, bring peace to the galaxy with the Galactic Federation Special Forces. And I would say to each of you, Universum Liberate. A great way to support the channel is by becoming a member of the Smash Team. By the way, smashomash.com/Smash Team. In 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade to the internet underground where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the videos, maybe you can hire the Smash Team. Of course, we're kidding, folks. Of course you can hire the Smash Team. There are links all over the internet to the Smash Team. Smashomash.com/Smash Team. There's a bronze level. There's a silver level. There's a gold level. There's a gold annual paid-up level. It's our own subscription services site. And let's get back to some more solar stuff here before we talk volcanoes and earthquakes. So there is All Souls Day and today to date. So November 2nd and November 3rd to date in SDO Continuum. We do have some more sunspots that will get named today. I don't think any new groups since yesterday's video, however. So we already could see these yesterday. Here's the colorized magnetogram for that same period from Solar Dynamics Observatory. And let's talk about Iceland. Yeah, Iceland. So major ground deformation and over 10,000 earthquakes happening there. Those are the quakes over a 1 magnitude. And those large red circles are 4+ magnitude quakes. That is the expected zone where there is magma intrusion happening at the moment. Exciting stuff there. A possible eruption about to happen there under Iceland. Could it be a massive one? Let us know in the comments what you think. And these are the rest of the volcanoes that are erupting on a global scale. So lots of stuff about the Reykjanes Peninsula. Of course, as there is 5 to 6 centimeters of ground deformation happening there. And lots of seismic activity. Also, Kluchevskoy continues to erupt in an explosive fashion, producing a 23,000-foot ash plume. Mount Mayan, unknown volcanic ash plume over Mount Mayan on the Philippines. Mount Ibu, 8,000-foot ash plume. It's a flight level 080 as it effuses and explodes. Semeru, also exploding, flight level 140. It's a 14,000-foot ash plume. Dakono. What do you got, Dakono? About a 6,000-foot ash plume over Halmahera. Shishaldin has simmered down there. Low-level ash emissions no longer detected at Shishaldin. Looks like it has subsided after producing a 20,000 to 30,000-foot ash plume. Popocatépetl exploding, flight level 200. Sangay exploding, flight level 200. Flight level 150 over Revenador. And an uptick there at Sabancaya in Peru as well. 24,000-foot ash plume, flight level 240. Please don't pole vault the caldera. And here come the earthquakes. For the past 24 hours, we'll call out the ones of a 5 or greater magnitude. Those are the past 90 days. First quake on the list is at the South Sandwich Islands region. That was a 5.1 at 23:57, 3 minutes before midnight last night. Next, there was a 5.1 at Greece. Check it out. 5.1 there at Greece. That was at 6:26 Universal Time this morning. And then only about 20 minutes later, a 5.0 at Alaska in the Aleutians. Then the Pacific-Antarctic Ridge had a 5.7 near the Antarctic/Pacific Plate boundary. Fiji then had a 5.3 at 11:54 this morning. These are all in universal time, by the way. That 5.3 was at over 550 kilometers depth. Then a 5.6 strikes Nepal. That one must have done some damage, as I see yellow on the shake map. That 5.6 was at 18:02 universal time this evening. And returning to space to take a look at another 24-hour video from SDO. There you have the house favorite 171 angstroms wavelength. And you'll be hearing a lot about this filament, which is likely to cause some geomagnetic storm conditions. We might even see something like a KP7 from that one. That is a nearly perfectly earthly directed coronal mass ejection. We'll tell you all about it in a little bit. Before we do that, let's talk about stuff like the radio flux. The 10.7 centimeter radio flux is now at 158 solar flux units. If you're wondering what a solar flux unit is, it's 10,000 Janskis, which is a type of measurement of electromagnetic radiation traveling through space. Radio flux at 158 solar flux units right there on the graph. That's a 1-year graph from Solon.info. The black line is the radio flux. The red line is the sunspot number, which has actually leveled out. It's actually higher than this depicts. The sunspot number is more like 130, I believe, if I remember correctly. And let's take a look at the NOAA Space Weather Enthusiasts dashboard. So NOAA's not forecasting any geomagnetic storms or geomagnetic unrest. We are expecting a CME impact to show up a little bit later than NOAA is. They're expecting it to hit with a glancing blow sometime between the 4th and 5th. We're expecting it to come later in the day on the 5th. So sometime after noon Universal Time on the 5th is when we're expecting it, possibly even on the 6th. So that's NOAA's forecast, a little bit different than ours. And there you can see that little CME about to, again, show up on November 5th there. We're expecting that to be a little bit more slowly moving than NOAA is. And here's NASA's Enlil spiral. Let's see what NASA's got in the forecast. NASA's expecting it to arrive about when NOAA is. So they're all calling that it moved a little faster than we are. Keep in mind, it is not our specialty calculating the speed of coronal mass ejections, although we have been quite accurate in the past about 12 Earth impacts. So again, we are expecting that a little bit later than NASA and NOAA. We think that'll show up sometime around afternoon on the 5th and into the 6th. So that's NASA and NOAA's forecast. We don't have any geospace magnetosphere movies for you, unfortunately, tonight, folks. They have been held up since Halloween. Check it out, 1031 at 1650. Also, the ground magnetic perturbations map is not updated. KP index is currently at 0.67. It is becoming quite geomagnetically calm indeed, quite geomagnetically calm. And so the next thing we'll cover here is the solar wind. So there is the solar wind from the ACE, and it's a great example of how the ACE and Discover often have completely different measurements. Here the ACE is only showing 338 kilometers per second. Check it out, 338, 332. And the Discover is showing more like 472, so quite a lot faster wind there at the Discover than at the ACE. We'll call out the stats from the Discover. About 4.5 protons per cubic centimeter for the solar wind density, solar wind velocity 472 kilometers per second. A pretty steady signal there on the Discover. GOES magnetometers here are pretty calm, and you can expect smooth readings until sometime on the 5th, I would say, for the GOES magnetometers. We might see a minor geomagnetic storm from that stealthy CME that we called out a couple of days ago. So we'll have to see what happens with that. And next, on to the top view ecliptic plane field plot, one of my personal favorites. And so what's going on here? Well, the sector boundary crossing is about 2 days out. So there's a North Pole current sheet headed your way. You can see it here in green. If we bring up the last image, there's that sector boundary crossing. Again, that's about 2 days out, maybe 3. It does depend on what the sunspots on the eastern limb do. They could drastically affect when that sector boundary crossing occurs. Next, our line of sight field plot. Here the polar fields are depicted in red and green for south and north respectively, the B field in blue, and the photosphere magnetism in gray. As we transition to our line of sight ecliptic plane field plot, there you go. There's a view of the polarity of the solar plasma. Again, red for south and green for north. Next, moving to coronal holes. And like I said yesterday, we've got some North Pole-oriented coronal holes here rotating in on the east. So right there on the eastern limb, just behind those new sunspots, we have North Pole coronal holes with a South Pole coronal hole right in the Earth-facing zone. There's the view from SDO 211 angstroms, the ultimate wavelength to view coronal holes. Okay. Next, let's talk sunspots, shall we? What do you think we should do? Just kidding, folks. This is a space weather dictatorship. So there's a sunspot situation. Let's see. We're at about 132, and it's leveled out here. Some sunspots have shrunk a little bit, but let's see. I think there are some that still haven't gotten named. So we are still going to be pushing up toward 150 because it'll be before those sunspots in the west set. So here's the flare monitor and scoreboard. And yeah, I think we've got 2 more groups that'll get names. So there's one here and there's one here. There might be one up here. I think there is one up there also. So we might have 3 new named sunspot groups. That'll be at least 18 new sunspots, probably more like 30 new sunspots. So we might even get up to the mid-150s, maybe even to 160 by tomorrow if we don't see degradation in the already visible groups. Next, the SDO magnetogram. There you go. There's a 24-hour video for you. And you can see not a lot of motions happening there. Again, most of these groups have been relatively stable over the past 24. We do have multiple locations where we could see large solar flares, and I would say those main locations would be this sunspot group and this sunspot group. This group in the east is quite complex and kind of jagged looking, and this one in the southwest has already produced some significant flares. We'll show you a breakdown of its magnetism before we get to our meteorology segment. And here's the SDO continuum for the last 24. So look, there's actually two sunspot groups that haven't been named yet there in the northeast. So we might have as many as 4 new named sunspot groups by tomorrow, folks. That would be an increase of at least 24 sunspots on the sunspot number. Again, assuming no other groups have degraded since then. Next, talking about solar energetic particles and flares. And so that's what's coming. Before we do that, take a moment to press the like button. Yeah, press like. Otherwise, there will be repercussions. We'll have less likes, and we can't have that. So press like. Congratulations on realizing the space weather, the ultimate, the most comprehensive daily space weather show in the known universe. Also the most detailed solar imagery you'll find anywhere. Right here at the Smash News Network, least busted name in news. So press the like button. If you're new to the channel, press subscribe. Thanks to everybody who has. Thanks to our new subscribers on YouTube. So as far as solar energetic particle events go, we had one. It was quite minor. It was associated with a CME and a long-duration C-class flare. It wasn't really very noteworthy, but hey, there's a proton spike, the first one in weeks. So a little bit of a tiny proton event happening there. Not likely to cause any polar radial blackouts. And here's the flare that caused it. It's likely this long-duration C-class flare. And that was also one associated with a coronal mass ejection, which we'll get to here. So the GOES X-ray flux has come up and up. It's in the past 24 hours, it's at about a C1, although recently it has dipped to a B9.3 or so. But the past 24-hour average is definitely well above a C-class. That is the one-day average. And here comes solar flares in 131 angstroms. Great view of that filament eruption there in that wavelength. And we'll also show 94 angstroms. And like I said, I suspect that proton event was associated with that coronal mass ejection. It might have actually been from the flare that preceded it. So that long-duration C-class flare came from right in here. I suspect the flare was associated with that proton event because it was too close to when the CME occurred. So yeah, some relativistic particles finally showing up as a coronal hole high-speed stream subsides. And have I mentioned that there are at least 2 coronal mass ejections on the way? We'll get to the latest here in just a moment. Before we do that, it's time for a star chart. So there's what's going on now. The sun has just set along with Mars over Lehigh Valley. And if you're viewing the early night sky, you might see Jupiter there rising in the east as Saturn gets close to the apex of its trip across the ecliptic. Both of our closest gas giants there, visible in the evening sky. Next, the solar system forecast. Here's where things are today. Don't you want to know where things will be in a week? That's where things will be on the 10th of November. We'll have a crescent waning moon as we approach my favorite phase, the new moon. Yes, the new moon. Next, our astronomy photo of the day. Check it out, a great photo of the moon and Jupiter. Yeah, the moon and Jupiter. You got to have it. And that image is so good that you can actually see Jupiter's moons. Check it out. You can see some of Jupiter's moons there. And a nice halo around the moon there caused by the prismatic effect of ice crystals in Earth's upper atmosphere, aka cirrus clouds. So that's apod.nasa.gov's Jupiter by Moonlight. And let's talk CMEs. Yeah, CMEs, it's exciting. Yeah, there's a second one on the way, so we can expect that one to arrive. Well, we'll get to it. We'll get to it. So here are 106 frames from yesterday. That's not earthly directed. That's not earthly directed. But there is one after that that is earthly directed. It's kind of stealthy. So that's 106 frames from yesterday. And here's where the real fireworks start. And by the way, expect coronal mass ejections to continue for the next 24 hours. Check it out. Crazy events going off here. So there's one out of the southwest, one out of the south. And then one kind of out of the north. So multiple events there happening in rapid succession. We'll break it down. Here's the C2 and C3. And here's a closer view. We've got the imagery on the left a little bit ahead of the imagery on the right. It does show time and date stamps in the lower left of each series of images. So there's one coming out of the south early this morning. And there's a second event out of the north. A third event out of the southwest. And you may see that eruption that looks like a halo. It's not as halo as it might look. But let's bring those back just a minute here. So that looks like a legit halo CME. It's actually two separate CMEs. You can see one event out of the south, and then a second event out of the north. And before we get to our custom coronagraphs, let's take a look at stereo A, located right here where my arrow is at the red circle there. Here's stereo A's coronagraph and difference imagery. So great views there from stereo A. Once again, we have the imagery on the left, the raw coronagraph, a little bit ahead of the difference imagery. So multiple events happening there, and at least one of those has significant earthly directed components, if not directed almost exactly toward Earth. It's not that spectacular one at the end, it's the one before that, just before midday. So we'll bring that back once again here. So here's one out of the south and the west, and then a second one out of the north. It's that one out of the north that's going to have a major earthly directed component. So it's not this first couple of events, it's this second one right there. That is a halo CME. You can see about 75% of the coronagraph has ejecta coming out from around it, an indication that a large portion of that is earthly directed. So there are some dense cores that aren't earthly directed, but you know, a large portion of that is earthly directed. And here are our custom coronagraphs. So that's a 24-hour video, SDO 193 angstroms plus the Soho LASCO C2 NC3 all synced up. And when we zoom in more closely, you'll be able to see the origin of that. It's this filament which partially ejected, partially remained anchored, and partially collapsed. So a great example of 3 of the 4 things that a filament can do. The other thing it can do is reposition itself and remain anchored. That's another thing that happens sometimes. This one basically stayed in place. Part of it collapsed and part of it ejected. So just fantastic imagery there. And another CME going to be arriving sometime late in the day on the 6th. So from the 5th into the 7th, we will have CME impacts. So we're expecting them to start sometime around midday the 5th, maybe a little later than that, and into the morning of November 7th. Here's a closer view. We've dropped the Soho LASCO C3 and added 304 angstroms to show some even further depth. That is pretty sweet. And here's the full disk with no coronagraphs. How you like them apples? Press the like button. Otherwise, we will find you and we will shame you. Press like right now. Do it. Do it. I implore you. Here's a close-up. And here's an even closer up. Great view of a Hyder flare there. The Hyder flare is the secondary solar flare that occurs when the plasma splashes back down, losing its magnetic field suspension, succumbing to gravity, and making its way back down toward the chromosphere, the transitional region in between the photosphere and the corona, which is the main portion of this imagery. So that's what's up. Next I'm going to go to Filaments from the Big Bear, California Observatory. There you go. And you'll note this huge filament right here. It's going to shrink. Whoops. Now it's much smaller. That's because part of it collapsed, part of it ejected, and part of it remained anchored. So massive filaments. We've got more rotating in here in the east. That one up there is huge. This one down here is really huge. That one's actually ejected as well. That's one of those CMEs that went off to the south. By the way, if you do social media, hit us up on Twitter. That's where the most interaction happens. Although the pathetic remains censorship, and the censorship remains pathetic. If you don't do social media, we don't blame you, but help us get to 500 followers on Twitter, as if that's some kind of a milestone. Yeah, 500 followers. We still don't have them on Twitter. Yep. Just over 22,000 tweets and daily original content, and putting up tweets every day with that original content since 2019. Less than 500 followers. Okay. As if space weather's not popular. All right, whatever, Twitter. Doing a fine job, Elon. Just a fine job. You've really restored free speech to the internet. Well done. Well done. Pardon the sarcasm. It's pathetic. So there's the grayscale imagery, and the reason we show this also is because it shows prominences, unlike this, which doesn't show prominences. And we've got a bunch, especially around the east. And before we get to bonus features, let's take a look at the most recent prominence, which is just kind of popping off over here on the west right there, catching the tail end of that. That's the past about 3 hours there from the GOES 16 SUVI. This filament up here looks like it's getting unstable. This filament up here is just massive. And again, folks, we do have multiple regions that could produce large flares. This area up here could produce a large flare, but especially this one and this one. Those are the three main spots. And what else do we have? Well, we have bonus features. Did you know we used to put them in a separate video and the meteorology in a separate video? And guess what that did? Got us less views on YouTube, so now they're all together. The space weather and Earth weather together. Satellite charging hazards are non-existent. It's smooth sailing for satellites. The GOES electron flux here kind of at high levels. Both the GOES 16 and the GOES 18 measuring warning levels of electron flux. That's the greater than or equal to 2 mega electron volt electron fluence, measured using radiography at the F layer of the ionosphere. There is the 1-year graph to contextualize the electron flux. Here's the forecast model. And NOAA is expecting a little bit of a dip here in the coming days. If we see a significant CME impact, we could see a major dip, which would be an erroneous reading. But in any case, don't be surprised to see a KP7 from that most recent CME that's earthly directed. We could see a significant geomagnetic storm from that one. So again, expect that to come late in the day on the 6th into early day 7th on the 7th. So 2 CMEs on the way, the 5th through the 7th, likely to feature some coronal mass ejection impacts. Next, the layer where it's measured, the F layer. It's about 300 kilometers of altitude, and here it is in vibrational frequency. So that's the ionosphere, and as we forecasted yesterday, you'll see a lot less low-frequency anomalies on this because of the subsiding of that coronal hole high-speed stream. It's just what you could expect to happen if you know how to forecast space weather, and many of our viewers probably do by now. As we empower our viewers to be able to do their own forecasts, we don't try to gaslight them and convince them that the past happened differently than it actually did. It's pretty easy to admit when you screwed up, folks. It's a lot easier than creating a series of lies to cover up your mistakes. That's not how science is done. Science is done by not being ossified in your beliefs and understanding when you are incorrect and learning from it. I know it's a crazy idea, right? Ooh, don't double down and triple down on being incorrect. Yeah. Here's the latest image. That's 2200 universal time ionogram, and there is the anomalygram. Great highlight there of the South Atlantic anomaly here, right over the South American continent. Bless you, Smash staff. Next, our whole atmosphere model, the Global Ionosphere Nowcast. Gives you a great idea of what's going on with GPS operation as well as radio operation. So that's the Ionosphere Nowcast, showing total electron content on the left and maximum usable frequency on the right. Next, total electron content, which is back. It was down yesterday, but now it's back. There's the global view. It still looks exceedingly low here. Not exactly sure why that is, if they've changed the scale or what, but I don't like it. It doesn't look right. So we'll show the total electron content anomaly from the 10-day average over North America. And this looks like legit data. It shows low electron count anomalies in blue and high electron count anomalies in red. And things are fairly steady over North America as far as electron counts. It's literally a count of electrons from about 12,500 miles down to ground level. There's the latest continuum. And there's the latest magnetogram. Let's check out these sunspots. So that one up there, that's a beta gamma class sunspot. This one down here is beta gamma class. It's lost its deltas, folks. No more deltas. It's becoming less likely to flare because of that, but more likely to flare as it reaches the limb. So we could see a flare here, we could see a flare here, and the third spot is right there. So we'll also take a look at this group. There you go. So first this one, which, let me see here. That is actually one sunspot, believe it or not. A huge spread between those umbrae. That is a beta. That is a beta. That one's just beta class, I think. Yeah, that's just a beta class sunspot. This one up here, however, is that one's beta gamma class. And again, we do have two other groups there in the northeast also, so I have as many as 4 new named sunspot groups coming tomorrow. This is where our space weather video ends and where our meteorology segment begins. So let's take a look at the jet streams of the eastern world to start things out here at the Smash News Network. Least busted name of news. By the way, this imagery is from nullschool.net if you want to break out your own. There are the jet streams of the eastern world. Shout out to our viewers from this side of the planet. Here are the surface winds, like sands through the hourglass of time. These are the surface winds of your lives. Here are the surface winds of the central world. Shout out to our viewers from the Europe, Africa, and the Middle East. Here are the jet streams of the central world. And here are the jet streams of the west. Shout out to our viewers under this map. And there are the surface winds. A strong low here is currently southwest of Ireland, creating some stormy seas and likely some good surf at Spain. Continuing on to our visible satellite, this is what's going on over the Americas. Look at that spectacular imagery, folks. Gotta love the visible satellite. It's my favorite thing about making these videos in the early evening instead of in the morning. And here we've brought in a close-up of the visible satellite for the mid-Atlantic states. So that's what's going on over my head. And if you're wondering where Smash staff and I are located, it's Lehigh Valley, Pennsylvania, one of the world's leading cycling communities. It's right about there. Somewhere, yeah, right about there. Lehigh County, PA, folks. Come visit, come ride your bike. It's the best. Anyway, now we're looking at snow depth for the northern hemisphere, and that is where the snow has currently been settling. Quite a bit there in Central Asia, I see. And all that hot air in Colorado has still not melted all of that snow. Colorado, the nation's hot air capital. Next, our weather.gov map. Weather.gov is where to go to get your weather warnings. There are too many counties for us to cover, although things are pretty calm at the moment. Weather.gov, if your location is lit up, click your location. Get your weather warnings. There is the key to show you what they mean, perhaps. And next, some forecast. The GFS 72-hour pressure and precipitation forecast is first. Some ice coming to Canada. And some heavy precipitation coming to the Pacific Northwest. 72-hour GFS pressure and precipitation forecast is what's depicted here. Next, the jet stream. The force of nature responsible for moving most weather from west to east. It's also responsible for moving cold air to the south in the northern hemisphere and warm air to the north in the northern hemisphere. So that's the 250 millibar winds, otherwise known as the jet stream. And last but not least, the temperature anomaly forecast. So the cold temperatures in the east are now subsiding. And we'll have a heat wave here moving across the central plains into the Great Lake states. That's a 72-hour GFS temperature anomaly forecast in degrees Celsius. Next, lightning, and we've moved our lightning mapper down because, well, it's autumn in the northern hemisphere, so you're not going to see much. But check out the lightning over the South America. Dag. Pretty bulky lightning down there. Dude, that's a lot of lightning. Shout out to Bruce. Bruce Minas. How you doing? Next, a real-time lightning map. And we've got some lightning, looks like in the Mediterranean there. Come on, then. There's your real-time lightning map. That's where the strikes are happening. We got some Atlantic strikes. We got some Caribbean strikes. There's one near the north portion of the Mid-Atlantic Ridge. A lone lightning bolt. Anyway, we'll close this thing out with Doppler radar. There's the full 50 view. We're focusing on the lower 48 view. Doppler radars are ground-based systems that measure vertical motion of the air column. The visible satellite is a space-based system that takes visible data. It's what the naked eye would see if it was viewing from space. And there's the water vapor satellite. That shows all the water vapor. It shows not just the moist air, but also the dry air. Here's a recap. Doppler radar. Visible satellite as darkness falls over the eastern U.S. And there's the water vapor map, which clears things up if your Doppler is unclear. When your Doppler's unclear, you heard it here. View the water vapor map. Anyway, CMEs on the way. Thanks for tuning in. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.